This is lesson 3.10, and it's the beginning on how to add and subtract rational expressions. Now, first, in order to add and subtract rational expressions, we need to go ahead and define the LCD, which is the least common denominator. And the least common denominator, it is the product of the factors of the rational expressions with each common factor used only once. And for example, this isn't in the notes, but you could find the common denominator of, let's say you wanted to find 3x and 4x squared, and you want to find the common denominator of these two. Well, 3x, first we look at the two numbers, and we want to find the least common denominator between those two, or also it's called the least common multiple. Denominator refers specifically to when you're a fraction and you're looking for the denominator, but the two are the same, one and the same, just a different application. So first let's look at 3x and 4x. Well, 3x is a 3 times x times x times x, and 4x is 4 times x times x. Oh, sorry. It's just a 3 and an x. And 4 is 4 times x and x. Now, it's the product of the factors of the rational expressions. So we could combine all of this together in order to find the LCD. But it says with each common factor used only once. So we look at common factors, which are the ones that they both have. Now, the common factors between these two is this one has an x and this one has an x. So first thing we have is a common factor. Then what we're going to do is we're going to find all the other factors that were not common factors. So let's say we look at the 3 is unique to this one, and so I'm going to have a 3 also, and then the 4 is unique, so I'm going to have a 4, and these are all multiplied together. And then this x over here doesn't have a common factor on the other side, so I have another x. And then we multiply this through, that tells me it's 12x squared. Now there's a shorter way with these types of problems. What you can do is find the common factor of the least common multiple of 3 and 4, which is 12 in this case. And then for x and x squared, it's always going to be the larger of the two. This works for these type, where you simply have a monomial that you're trying to find the common factor of. And they're both monomials, but in some cases you'll have a binomial or even a trinomial, in which case you have to use another method. But this is the basics of how it works. You look at duplicates, put those down, the ones that the common factors that they each have, and then you look at unique factors. So that was the way you factor it out, and then you use that method. Now let's talk about, do an example. When we're trying to add rational expressions, the denominator must be the same. Similar to if we said 1/2 plus 1/4, the denominator here is not the same, so we have to change it. We multiply by 1 to change this problem to 2/4 plus 1/4. Now we have the same denominator, and we can add those, and that's a total of 3/4. So a 1/2 cup plus a 1/4 cup is 3/4 of a cup. Now, in the case of rational expressions, this is example 1a. If we have 3 over 8x plus 4 over 8x, we have the same denominator, so we simply add the numerators. 3 plus 4 is 7, and then the 8x stays the same. So we add the numerator. Okay? And then it's over the same denominator. And this is how we add fractions. Now for b, we have 2x plus 9 over x plus 1 minus 7 over x plus 1. These have the same denominator, so we know it's going to be x plus 1 in the denominator. And we can add the numerators. 2x, there's no x's over here, so it's simply a 2x. And we're going to combine the like terms. 9 minus 7 is a 2. And it should be positive. Now, look at your final answer. Do you notice that this actually, the numerator can be factored? So if it can be factored, that means we can reduce it. So 2x plus 1 is how I would factor the numerator. And then the denominator, I still have x plus 1. Now let's evaluate this. Can it be simplified? And you see here, we have an x plus 1 that can be simplified. So your final answer is simply 2 for that problem. So with all of this complicated setup, the answer actually is a whole number of 2. If we look at the next problems, 1 and 2, the sample problems, we have 1 is x plus 8 over 4x plus 3 over 4x. And this has the same denominator, so we simply say x plus 8 plus 3, which is x plus 11 over 4x. And that is your answer. Simply add the numerators. For 2, we have 8x minus, it's a 6. 6x minus 5 over x minus 2x minus 5 over x. So add the numerators. Denominator is going to stay the same. We add the numerators, but it's a minus here. So be careful. 6x minus 2x is 4x. Negative 5 minus negative 5, that becomes a plus. So that becomes a 0. And you can either write plus 0, but I'm going to leave it out because I want to show you something. When you look here, 4x and x have a common factor and it can be reduced. 4x, the x's actually cancel out, and that simply becomes 4. So 2 things, be careful of your negative. A negative and a negative is a positive. And then once you're done, see if there's anything that can be factored or reduced after you get your final answer. For example 2. Example 2 is just finding the LCD. It says find the LCD. And when they ask you to find the LCD, we're only going to look at the denominators. So for example 2a, we have 1 over 3x cubed, and then we have 5 over 4x to the 4th. So we're focusing on these denominators in order to find the least common denominator. Now 3x cubed is equal to 3 x, x, and then 4x to the 4th is equal to 4 x, x. Now you notice we have some common denominators here, so we're going to use those for our LCD. We know we have 3 x's that are common, and then we look at our unique numbers. 3, we have a 3, a 4, okay, I have a 3, a 4, and an x. So a 3, a 4, and then another x. And then let's combine all of that together to get our final LCD. 3 times 4 is 12, and then 1, 2, 3, 4, x to the 4th. So that is the LCD between 3x to the cubed and 4x to the 4th.